Okay, we have another example of rational function. We're going to use our steps and our tools to sketch a graph. Start off with the domain. We want the values of x. We want to find the values of x that we need to exclude. So we set the denominator not equal to 0. We solve for x. So we get x not equal to plus or minus 5. So we have two values that are excluded from the domain. The next step is the vertical asymptotes, but we also want to just check, make sure we can't cancel anything, any factors, top and bottom in our rational function. It is actually in fully reduced form. There's no factors that we can cancel out. So our domain, or I'm sorry, our vertical asymptotes, we're going to have two of them. It's going to be both of those values that are excluded from the domain. So x equals 5 and x equals negative 5. Let's look at x-intercepts. So here's where we set the numerator equal to 0. We're going to solve for x. So we get x squared equals 0 over 2, which is just 0. Take the square root, we get x equals 0. All right, so that means our x-intercept is 0, which when we find the y-intercept, we're going to find it is the same. Evaluate at 0, we get 2 times 0 squared, which is 0. And then we get 0 minus 25, so it's over negative 25, which is equal to 0. All right, so x and y-intercept are both 0, 0. Next step, horizontal asymptote. So this is where we look for the degree in the numerator, which is 2, and the degree in the denominator, which is also 2. Those are equal. And when we've got equal degree, our horizontal asymptote is the leading coefficient in the numerator over the leading coefficient in the denominator. So that's a 2 over 1, or just 2. So a horizontal asymptote tells us that as x values go to the left and the right, plus or minus infinity, the function values are going to this fixed value of 2. They're never going to equal it. They're not going to cross that horizontal line or touch it, but they're just going to get really close to it. Okay, now let's look at our critical values. So we've got we've got two vertical asymptotes at negative 5 and 5, and we have got x-intercept at 0. So let's look at the intervals of values that we need to test out. Negative infinity to negative 5. And if we pick a value where it can pick negative 6, we plug that in. 2 times negative 6 squared over negative 6 squared minus 25. Well, that is 72 over 11. And that's equal to 6.5. It's positive, so we'll be above the x-axis there. Now let's look at negative 5 to 0. We can choose a value. Let's choose negative 1 that's in that interval. So we get 2 times negative 1 squared over negative 1 squared minus 25. Oops, I don't know where 24 came from. There we go. And that's equal to a 2 over 1 minus 25, which is negative 24, which is negative 1/12. And that is less than 0. See, I didn't do a very good job of writing that fraction. Let me do that again. There we go. That's less than 0. It's negative, so we're going to be below the x-axis on that interval. Now, next interval is 0 to 5. If we choose f of 1, because we're squaring x, we're going to end up with the same thing, right? It's just going to have 2 times 1 in the numerator and then 1 minus 24 in the denominator. So we're going to get 2, I did it again, 1 minus 25 in the denominator. So we're going to end up with 2 over negative 24 or negative 1/12. Again, less than 0 or below the x-axis. It didn't alternate like it has so many times. Now, our last interval is 5 to infinity. Let's choose 6. And same thing, because we're squaring that x, we're going to end up with the same thing, 72 over 11, or 6.5, which is positive, so we're positive there. Okay, let's use all these things to sketch a graph. Okay, so we can put in our vertical asymptotes at 5 and negative 5. And then negative 5. In our horizontal asymptote, which is y equal to 2. Okay. Now let's put in x-intercepts, and we have x-intercept at 0, 0, which is also our y-intercept. Okay, and we can also now plot some points from when we did our critical values. We have the point negative 6, 6.5. Okay, so I didn't quite go far enough up, but it's going to be about right here. And then we have the point negative 1, negative 1/12, so something like that, and then 1 and negative 1/12, and then positive 6 and that's 6.5. Okay, now it doesn't seem like we have a whole lot on there, but remember those asymptotes are really going to tell us what to do. Okay, so I'm going to expand this a little bit, or make it so we can see. I'm going to erase this. Okay, and then I want to make actually erase a little bit more. There we go. Okay, and let's expand or make this go out a little bit farther. And while we're at it, I can't erase. I'm not sure I am not able to erase. There we go. Okay, I'm going to give myself more asymptotes to work with. Okay, so remember, the horizontal asymptote is what happens when x values go to negative infinity as we go to the left. It needs to approach that horizontal asymptote, get closer but not touch. And as we get closer to that vertical asymptote, our choices are to go up to positive infinity or down to negative infinity. Well, since we're above the x-axis on this interval, our choice is to go up. All right, now let's just go over and do this other part too. So we got a similar thing going on. As x values get larger, we know because of that horizontal asymptote, the graph is going to get closer to that line, and we're positive and above the x-axis for this interval. So as we get closer to that vertical asymptote, we're going to go to infinity. All right, now let's look at what's going on in the middle part here. So our our intervals from -5 to 0 and 0 to 5 were all negative, so that means we're going to be below the x-axis. So we're going to connect these points, and then as we get closer to that vertical asymptote from the right, we're going to approach that horizontal asymptote, or we're going to approach that vertical asymptote, and as we approach x equals 5, we're going to approach that vertical asymptote and go to negative infinity. All right, so there is everything we need to know about that rational function graphed for us.